All right, here we are with functions 2, lecture example 3. This function may come up later in the class. I may use it later for something else. It is a rather complicated function, but it's good for an example. All right, so in a previous video I talked about what n cross n looks like, and here you'll notice that we're using, instead of n cross n, we're using z plus cross z plus. So let me just talk a little bit about what z plus crossed with z plus looks like. Remember that z plus is all the positive integers without 0, whereas the natural numbers is all the positive integers with 0. So not a whole lot different here, but in any case, let me draw it. Okay, so you got z plus and z plus. So 1, 2, 3, 4, 1, 2, 3, and up like that. Okay, so here's our domain. And remember, our target is the natural numbers. So we'll have 0, 1, 2, 3, 4, and so on. All right, now our domain, well, these are points where each of the x and y coordinate are positive integers. So we're going to have these points like this one, 1, 1, it's right here. 1, 2 is right here. Over 1 up 3 is right there, and that just keeps on going. You got 2, 1. See, we don't have anything. We don't have that, right? Because that's on the that's on the x-axis. And that would make the x coordinate 0. We don't have 0 to choose from in this case, right? Because we're just doing z plus. And so on and so forth. Okay. So this is our domain. And now let me just draw a few of these over to things. Okay. Now let's see. All right, so our function, let me just write it out here. We've got f of mn is 2 to the m minus 1 times 2n minus 1. All right, so let's see, if we put in 1, 1, right, 1, 1, 2 times 1 there. Okay, so here we get 2 to the 1 minus 1. 2 to the 1 minus 1, that's 2 to the 0. 2 to the 0 is 1. 2 times 1 is 2. 2 minus 1 is 1. Okay, so here we get 2 to the 0 times 2 minus 1. 2 minus 1 is 1, so this guy goes to 1. All right, so 1, 1 goes across to 1. Now let's put in a 2. Let's look at 2, 1. 2, 1 goes to 2 to the 2 minus 1 times 2 times 1 minus 1. So that's 2 to the 2 minus 1 So 2 minus 1 is 1, so that's 2 to the 1 times this quantity here, 2 times 1 minus 1. So that's still 1, so here we get 2. So 2, 1 goes over to 2. This guy right here goes over to 2. All right, now let's see, how are we going to get a 3, right? How would we get 3 out? How would we get an output of 3? Now let's think about how this has worked so far, right? When you put it, so look what we have here, right? I put 2, 1 into the function, what I have here, 2, 1, right? And we get 2 to the 2 minus 1 times, right? So we got a, all right, now 2 to any power, right? This part right here is what creates the evens, and this part right here is what creates the odds. Right, so if we have a 1 right here, meaning a 1 right here, then we get we get powers of 2. Sorry, not all evens, but powers of 2. All right, so let's think about how can we get 3 out? So let's put a 3 here. All right, so we want to get 3 out. Now, let's see. If we put a 2 here, then that's going to be 2 times 2 minus 1. So that's going to be 4 minus 1, which is a 3 here. So then we want a 1 here, right? How do we get a 1 there? Well, if we put a 1 there, right, then we have 2 to the 0, which is 1. So that means we want 1 over 1 up 2. So f of 1, 2 over 1 up 2 goes to 3. So that's 2 to the 1 minus 1, which is 2 to the 0, which gives me the 1. And the 2 there gives me 4 minus 1, which is 3. Okay, so 1, 2 over 1 up 2 goes to 3. So now let's think, how could we get a 4? So we want to get 4 out. Okay, so 4, right, this is what gives you the power of 2. This is what gives you a power of 2. So 4, to get a 4, we want to get, remember 4 is 2 squared, right? 4 is 2 squared, and then we want a 1 here. To get that 1 there, we'll put the 1 there, right? Because that's how we have 2 times 1 minus 1, that gives me 1. And then if I need a square there, so what minus 1 gives you 2? Well, that's 3, right? So you have 3, 1. So f of 3, 1 gives me 2 to the 3rd minus 2 to the 3 minus 1 times 2 times 1 minus 1. So 2 to the 3 minus 1, that's 2 squared, so that's my 4. 2 times 1 minus 1. This part right here gave me the 1, so I have 4 times 1, which is 4. All right, so over 3 up 1 sends me to 4. Now the question, so it's appearing that, okay, right. So now we can fill in this table, right? So let's see, 1, 1 went to 1, over 1 up 2 went to 3, 3, 1 went to 4, right? That's what we just found. Okay. And yeah, so let me be clear, right? To fill out this table, you wouldn't need to draw this thing that I've drawn over here. I just want to give you a visual representation of what's going on. To actually compute this, all you'd have to do is just put the numbers in here. So I'll do that with this one, 4, 5. So that's 2 to the 4 minus 1, 2 times 5 minus 1. 2 to the 4 minus 1, that's 2 cubed. 2 times 5 minus 1 is 9, right? So that's 9. This is 8, 9, so 72. 72. So we put that over here, 72. 72 is a natural number, so it is in this set. I just didn't write it before. So 4, 5 over 4 up 5, somewhere up here, right, goes to 72. All right, let's see, what went to 2? Backtracking, that was over 2 up 1. So 2, 1. Let's see, right, that was that one. That was, right, okay. And now, let's see, is there anything that comes over to 0? All right, so we want to find, is there anything we can put in there? And it sure doesn't look like it, right? Judging from what I have drawn over here, it sure doesn't look like there's anything that comes over to that. But let's try and argue that that can't happen. All right, so we have this rule, f of mn, so that's 2 to the m minus 1 times 2n minus 1 equals 0. So is that possible? Is there anything that can make that work? Now remember, m and n are only positive integers. So you put a positive integer, a number, one of the numbers like 1, 2, 3, 4, 5, 6, 7, 8, like that, into there for m, you're going to get something. You're going to get something other than 0, right? And the same thing goes over here. You put 1 or 2 or 3 or 4 or 5 onto infinity in this thing. In this side over here, you're going to get something that's not 0. So two things that aren't 0, when you multiply them, you're not going to get 0. Right, remember we have this rule. It's called the, what is that? The zero factor property, that if you have, let me use some other things, say if uv equals 0, then that means that u equals 0 or v equals 0. Now 2 to the m minus 1 is never going to equal 0 when m is a positive integer. And 2n minus 1 is never going to equal 0 when n is a positive integer. All right, so we have D and E here. And now just check real fast, is everything on this side over here, are all the numbers unique? Yes, they are. Are all the ordered pairs unique? Yes, they are. Okay, so we have a D and E at 0, so our answer there is 0. And I'll do another video on for 3C.